The whole methane performance certificate, that the project for us, I mean, our MO is sort of like find a process or a framework or whatever to figure out, can we automate it using our AI technology or machine modeling and whatnot. And we got there pretty well. But then, we've since then moved on to other certifications like the ISCC and the ISO 14067 and whatnot. But that work, trying to automate the methane performance got us in the game. And we ended up working with Jana Broderson and then hiring her to, because she's got this chemical engineering, professional engineering background. And she's the one that introduces to mass balance, like the thing you need to do to solve this. For us, we were always marrying our monitoring with our camera technology and then with this measurement technology. But there's one problem we have, okay, and that is people say, hey, I'll go full field on the measurement side, which we call proof zero, but I kind of only want to put your super duper deluxe Minerva camera systems on maybe 10, 20% of my highest producing sites, which leaves 80% of my upstream sites not covered at all by a camera. And so, we're facing that dilemma and like, well, how are we going to solve that problem? And then, Mark, Chris, and you both reached out to me and said, well, maybe we have a solution. So tell me about Geo Financial and what Geo Financial does.
Yeah, so I've been working with Mark Chris, the CEO and Geo Financial, for a little while. And so we're looking at and taking some of the publicly available satellite data. The team's been funded initially partly through the National Science Foundation to really look at how do we create algorithms and stuff. We've got a great data science team to take publicly available satellite data and actually attribute methane to individual assets, which is a level of detail that's really important, like you said, in this kind of resolution, as companies are really trying to understand what their footprint looks like. And so the team's been able to start looking at that, which has been great. And I think for us, really understanding the role of satellites has been really important, because for a lot of people that are in the methane detection space, there's different resolutions of different measurement techniques. And I know we'll probably get into some of that in a little bit more detail. But for us, it was really figuring out where do we fit in the methane detection space, and what role can we play with satellites, because they don't always have the highest threshold detection to be able to detect methane. So sometimes on their own, they can be a little bit of a challenge, but they are really good at detecting large unexpected leaks. And like you said, they can fill in the gaps. We have much higher resolution in terms of what we can see with a satellite, just because of, how high above the ground it is versus being, right at that source. So allows us to fill in some of those gaps. And the other piece, and there's still some challenges in this, but it also allows a bit of an independent verification of some of those on the ground measurements. I think one of the things that's still really important for people to understand is that we still calculate emissions. We measure things like methane concentration and stuff like that, but we still do need to do some calculations. And once methane, and all emissions, but we're talking about methane here, once it's outside of a pipe, we have to also account for things like weather and wind and all these other things that we need to also calculate and things like that. So having sort of these multiple data sets as well, so that we can sort of independently verify and corroborate on the ground measurement data and reporting and all these kinds of stuff, is also another really good use of the satellites as well. So yeah, it's been a really interesting, fun journey as we sort of look at the data set and what it's really capable of doing.